Hi, Astronomy. This is Mr. Janowski with the last part of the Chapter 1 Cycles of the Sky slides. So there's two things to do for homework. One is there's a quiz on Google Classroom, and the other thing is you have to do 1/4 of the study guide. So here are the groups, and I have divided up the study guide into four roughly equal sections. They're divided up by topic, basically. And so if you're, whatever group you're in, do those questions. So yeah, in this last part, we're going to talk about the moon because the moon is totally a thing, and the moon does interesting things in terms of the cycles of the sky. So the moon also rises in the east and sets in the west. Yeah, everything that rises and sets does so because of the Earth's rotation. They're always going to rise in the east and set in the west. So the moon is not stationary on the celestial sphere. So the moon doesn't sit put and stay with the exact same background stars right behind it. The moon moves around across the celestial sphere. The actual stars in the celestial sphere, they stay relatively locked in place over tens of thousands of years. Those barely seem to move relative to each other, but the moon moves around, the sun moves around, the planets move around. So if you were to watch the moon carefully, you would notice it's moving. Now, don't stare at it and expect to notice it moving because it happens too slowly for that. But if you were to make a note of the position of the moon compared to the background stars, so perhaps the moon is directly next to some particular star in the background. If you go back an hour later and look at it, the moon will have moved. And how far will it have moved? Well, it will have moved about one width of the moon. So that's what that means. So the most striking feature about the moon, this is something, our species has known for our entire existence. And one of the first things you learn when you're a kid about the moon is that the moon changes shape or appears to change shape. It doesn't really change shape. The moon is actually just a big sphere up there. And the moon goes through phases. So it takes approximately 29 and a half days for the moon to go through all of its phases. So you may notice that 29 and a half is pretty close to a month. Yeah, that's not a coincidence. Month comes from the word for moon. So if we look at the middle picture, this thing right here, you'll notice that at all times, the moon is half being lit by the sun and half in darkness from the sun. So it doesn't matter where it is in any of the phases, the moon itself is always half lit up and half in darkness. The one exception being when you get to lunar eclipses and the moon is in the Earth's shadow, well, then it's not half lit up by the sun because it's in the shadow. Um, but other than that, yeah, the moon is always 50% lit by the sun and 50% in darkness from the sun, in shadow of the sun. You know what I'm saying. So, yeah, if that's true, if the moon is always 50-50, bright and dark, why does it seem to change shapes? It's because the moon is going around the Earth. So the Earth is spinning. That's part of this. So the Earth is spinning. It's going around counterclockwise. So we're looking down on the North Pole here. But the reason the moon appears to change shape is because it's revolving around the Earth. So the Earth is rotating on its axis. The moon is revolving around. So that is where you get the changes in shape from. So start right here at new moon. So again, the moon itself is 50% being lit by the sun and 50% in darkness. But the new moon looks the way a new moon looks because the side that's facing the Earth is the dark side. So you don't see the new moon. And the question down here is the invisible new moon above the horizon during the day or the night? We'll look at the picture. So this is the light side of the Earth, and we're looking at the dark side of the moon. So that means the moon is up, a new moon is up during the day. So a new moon will rise and set with the sun. Now, because the moon is revolving around the Earth, as this is going on, and the Earth is spinning, the moon keeps going a little bit eastward against the background stars every single day. So what does that mean? So we'll start here at new moon. So you're facing the new moon. Okay, so the new moon is directly overhead at noon is what's happening if you're right here on the Earth. So the Earth will rotate around. Takes 24 hours to get around. And while that's happening, the moon wasn't staying put. The moon has moved a little bit. So the moon will be down here a little bit. So it's going to rise about 50 minutes later. And it's going to set 50 minutes later. And so day after day, if you keep adding these 50 minutes up, the moon will appear to rise and set later each day until eventually, the things change. So we went from here all the way around to here. So here's a full moon. So when does a full moon rise and set? A full moon will rise at sunset and it will set at sunrise. So yeah, going around like this. Yeah. So a full moon is completely a nighttime object. It comes up, it rises over the horizon at sunset, is up all night, and then at sunrise, the full moon will set. So when does the third quarter moon rise and set? So the third quarter moon is this one, so it's 7. So what's going to happen here is the third quarter moon is going to rise in the middle of the night. So if you're on the Earth, so the moon will be here. So you're on the Earth, you're rotating around like this, okay? And at this point, for you, the sun has set. And you can't see the new moon yet. It's still below the horizon. And the Earth keeps rotating around. And when you get to about here, so this will be about the middle of the night, now you will see the third quarter moon rising. So you'll see it as you come around here. And then at sunrise, the third quarter moon will be directly overhead, or at its highest point in the sky at least. And then another 6 hours later, in the middle of the day, is when the third quarter moon will drop below the horizon. So that's how that works. So the moon takes 29 and a half days, a month, to go through a full cycle of phases, but it only takes 27.3 days to complete its motion through the constellations of the zodiac. So why is this? Why is there this little difference? It's because not only is the moon revolving around the Earth, but the moon-Earth system is also revolving around the sun as this is happening. So we will start up here. So if you'll notice, think of the sun as at the center of a giant clock. And right now we're looking at the Earth-Moon system when they are at 9 o'clock. So straight to the left, 9 o'clock. And at this point, now if we think of a second smaller clock, the Earth-Moon system is now a smaller clock. The Earth being at the center of the clock face. The moon is at 3 o'clock. Okay, so this all lines up. This will be a new moon for us. And then what happens is the moon, day after day is revolving around the Earth. And while this is happening, the Earth is also, or the Earth-Moon system, is also revolving around the sun. So 27.3 days later, we get to here. And notice the moon is again at 3 o'clock relative to the Earth. So it has gone all the way around. So in a sense, the moon has gone all the way around. This is 27.3 days later. But it doesn't line up with the sun anymore. Or I'm sorry, it doesn't line up with the sun again yet, is how I should say it. Because the Earth has moved about 1/12 of its way around the sun, so it's not lined up again yet. It's going to take another 2.2 days till we get to here for the moon to line up, and so we have another new moon. So that's why there's this discrepancy. And that is what these slides are explaining here. Everything I just talked through. So now we talk about eclipses. Eclipses are very cool. So sometimes during a full moon, the sun is on one side, the Earth is in the middle, and the moon is on the other side. You can get a thing called a lunar eclipse. So that is when the moon falls into the shadow of the Earth. So up here we're looking at sun on one side, Earth in the middle, and this would normally be a full moon, but instead we're going to get a lunar eclipse. So what happens is, the light from the sun, the Earth casts a shadow from the light from the sun, and the moon is going to move into that shadow. So when this happens, the moon is in shadow, but it's not completely dark. If you've ever seen a lunar eclipse, it's not that the moon disappears completely. What happens is it kind of creepily turns this red color. And the reason why is because of some weird properties of light. So the sunlight is coming past here, and geometrically, you would think the moon would just be in perfect shadow. But what actually happens is the sunlight comes through here, and for different chemical reasons, it's called Rayleigh scattering. The blue light and the green light and like the shorter wavelengths tend to scatter away and they go off in different directions. But the red light gets refracted onto the moon. So this is why if you're looking at a lunar eclipse, instead of the moon being just dark or completely missing, it's going to be this very weird red color. So it's pretty cool. And another thing to point out is when you have a lunar eclipse, everyone who's on the night side of the Earth at that time, so if we're looking at this picture, all of these people are on the night side of the Earth, all of these people will see the lunar eclipse. So this is why lunar eclipses, people will see more lunar eclipses in their life than they will solar eclipses. Because whenever there's a lunar eclipse, basically half the world gets to see it. Solar eclipses are much more rare. It's not even that they happen less often, it's that when they do happen, fewer people on the Earth will see them at any given time. So solar eclipses happen during new moons. So sun is there, the moon is between the Earth and the sun. It all exactly lines up. So now we can get a solar eclipse. So notice the solar eclipse is when the moon shadow passes over the Earth, but notice that because the moon is so small compared to the Earth, its shadow doesn't cover the whole Earth. So it's only going to leave a little streak going across the Earth. So in this particular case, it looks like our total solar eclipse is passing right through the Strait of Gibraltar. So right between the southern tip of Spain and the northern tip of Africa right here. So only if you're along this path will you see a total solar eclipse. And if you're a little bit further away, you'll see a partial eclipse. So solar eclipses much harder to see because when they happen, only a small sliver of the Earth gets to see it, unlike a lunar eclipse. Again, a lunar eclipse, half the world gets to see a lunar eclipse whenever that happens. Solar eclipses are much harder to see. So yeah, when this happens, this is crazy. I've never seen a total solar eclipse. I remember the partial one from about 3 years ago. That was really cool. But I've never seen a total solar eclipse. I'd like to soon. But I know from watching videos and watching the internet that total solar eclipses are crazy when they happen. So a bunch of weird stuff happens. It will get completely dark. It will be dark as night. The sun will basically completely disappear. And instead of seeing the sun, you will see the atmosphere of the sun. And the stars will come out at night behind the sun. I'm sorry, the stars will come out at day behind the sun. And it'll start to get very cool. And all the animals will freak out because they won't have any idea what the hell is going on. So it gets very weird. So someday I hope to see one. In fact, in about 4 years, I hope to see one. So these are all the paths of different eclipses that have happened and will happen. So the one that happened in 2017 is this one. So it started out in the Pacific Ocean. The path of totality, this is called, went across through like Washington and Oregon, dipped down a little bit south, went through Nashville, Tennessee, I think was the closest big city to where we were, and then it disappeared out here. So that was 2017. This arc right here is the one that's going to happen in 2024. So in only about 4 years, we'll get another one. We won't have a total solar eclipse where we live. We will get a partial solar eclipse. So that one's going to pass up through there. So here we're looking at a view from space. This picture is really cool. This is the spot of totality, and this is going to move across the Earth in a path of totality. So yeah, just really neat looking from space. So this is a really weird coincidence, and this hasn't always been true, and it won't always be true. But now in 2020, and for thousands of years, actually millions of years before this and after this, but still not always, the sun. Okay, let me rephrase this. The sun is about 400 times the diameter of the moon. That's been true for a long time. The thing that isn't always going to be true is right now the moon is about 400 times closer to the Earth than the sun, which means they have about the same apparent size in the sky. And that is totally a coincidence. There's no real reason that has to be. And it won't always be true, but it is true now. So they're about the same size in the sky. The catch to that is the moon orbits in an ellipse. So it doesn't orbit with a perfect circle. Sometimes the moon is closer. That's called its perigee. And sometimes it's further away. That's called its apogee. And it varies by a good amount. It varies by about 10%. The moon's closest to its furthest distance. So what that means is sometimes the moon is a little bit bigger in the sky. We call these supermoons and things like that when it's at its perigee. And sometimes it's smaller when it's at its apogee. Well, when the moon happens to be a little bit further away than usual, so when it's at or near its apogee, its furthest distance, the moon is a little bit smaller in the sky. And in fact, it will be just a little bit smaller than the sun is in the sky. So if you happen to get a total eclipse during that time, or when you should get a total eclipse, instead, because the moon isn't quite big enough to cover the sun, you'll get this thing. This is called an annular eclipse. Annular means ring-like. Like annulus is, I think, Latin for ring. So you get this annular eclipse, this ring eclipse, which is really, really cool. And I would love to see one of these too. But if I had my choice, I would rather see a total solar eclipse than an annular eclipse. So as amazing as this looks, I just like my mind is blown by looking at this image. As amazing as this looks, you don't get all of the really cool things that happens during a total solar eclipse. So the sky won't get completely dark. It will still be bright because you can still see part of the sun in the sky, and you won't be able to see the clouds up at night or during the day again. And it'll get cooler, but it won't get quite as cool as it would during a total eclipse. So something that's really neat is we can measure the distance from the Earth to the moon very, very precisely. And it turns out that the moon is moving away from the Earth very, very slowly, about 3.8 centimeters, which is only about an inch and a half. Every year, on average, the moon gets about an inch and a half further away. So in 620 million years, that inch and a half times 620 million years is going to mean that the moon is so far away from the Earth that it will never again appear to be as big as the sun in the sky. So after 620 million years, no more total eclipses. If you get an eclipse, the best you're ever going to get is one of these annular eclipses, which is kind of sad if you think about whatever we'll be living here on Earth in 620 million years. No more total eclipses, but we have bigger problems at the moment than that. So this is neat too. These are solar eclipses, partial solar eclipses or annular eclipses, but not from Earth. These are eclipses on Mars. So Mars has two moons, but they're both small. They're both kind of dinky, crappy little moons. They're Phobos and Deimos. I'm pretty sure Phobos is the bigger one. So whenever there's a solar eclipse on Mars, whichever moon is covering it isn't nearly big enough to cover the whole thing. So you only at most get these annular eclipses, these very, very partial type eclipses. And again, I'm just amazed that we as a species are so very good at technology that we were able to put a remote control car, the Curiosity rover, on Mars with a camera, and we were good enough at figuring out where everything was that we knew exactly when there would be a annular eclipse on Mars. So when that happened, we told our little rover to point your camera up at the sun and take this series of images. So just really neat stuff. So good for humanity. We're very, very clever. So if we're looking at this image to the left, during which phase of the moon is a solar eclipse possible? You only get solar eclipses during new moons. So only when the moon is between the Earth and the sun can you get a solar eclipse. And when can you get a lunar eclipse? Only during full moons. So only when the Earth is in the middle, in between the moon and the sun, do you get lunar eclipses. Now the thing is, you get a new moon and a full moon once a month, which means you get 12 of each every year, but there aren't 12 solar eclipses or 12 lunar eclipses every year. So why is this? The reason is, this is a little bit tricky. So the plane of the Earth's orbit is called the ecliptic. So that's this blue plane right here. So here's the plane of the Earth's orbit, and the moon's orbit around the Earth is not exactly in that plane. It's tilted by a small amount, only by about 5 degrees. So what that means is, the Earth always casts a shadow, and the moon always casts a shadow. But sometimes you may have a new moon here, and you don't get a solar eclipse because the moon shadow is going to miss the Earth. So in this picture, it looks like it's below. So south of the South Pole, basically. And over here, we have a full moon, and so everything's lined up. You think you might get a lunar eclipse, but you don't because of that tilt. The Earth's shadow is missing the moon. So, yeah, the reason why you don't get one, every month is because the plane of the moon's orbit around the Earth is tilted in reference to the plane of the Earth's orbit around the sun. So, yes. The thing is, the moon will basically maintain that tilt pretty well, which means twice a year, everything will line up correctly. So in this picture, this is what we just looked at. This picture here is basically this picture here. But 3 months later, even though the orbit is still tilted, the plane of the moon's orbit is still tilted, the moon is at that part of its orbit where it is going to cast a shadow on the Earth. And 2 weeks later, the Earth will cast a shadow on the moon. So yeah, this is why we get eclipse seasons. You basically get 2 eclipse seasons every year. And whenever you get to eclipse season, that means you have a solar eclipse and a lunar eclipse occurring, and they'll be about half a month, 2 weeks before or after each other. So it depends on what's going on exactly, which one will happen first. But for example, our wonderful solar eclipse in 2017 was on August 21st. So we got to see that here, or at least a partial solar eclipse from Pennsylvania. And 14 days before that, other parts of the world, Europe, Africa, Asia, and Australia, they got to see a partial lunar eclipse because that was eclipse season that year. So this, you know what, I'm just going to skip this because it's not on the test. Basically, it says that the tilt of the moon's orbit in reference to the Earth's orbit around the sun precesses. So it precesses much more quickly than the tilt of the Earth's axis precesses, which is 26,000 years. The tilt of the moon's orbit around the Earth precesses, and it goes all the way around every 18.6 years. The result of this is that eclipse season happens about 20 days earlier each year than it did the previous year. But this is more detail than we need to know. So again, you have 2 pieces of homework due for next class, Monday. There's the quiz on Google Classroom, and also do your 1/4 of the study guide. And these are the groups, and these are the questions that each group is responsible for. So hopefully you found that helpful.